Good morning. Today I am going to discuss one of the fax device which is called static synchronous compensator or STATCOM. Now what is STATCOM? Basically it's a shunt connected device which is first acting device and capable of generating and absorbing reactive current or power so that it can regulate the voltage at the point of connection. So what is actually means as it is a shunt connected device, so there will be a common point where the STATCOM will be connected. So at that point this device is able to regulate or control the voltage. Now how that control of voltage is possible with the help of STATCOM? By regulating the reactive current or reactive power at that node, or we can say bus. Now this figure shows the basic structure of a STATCOM, where it consists of a voltage source converter and a DC link capacitor, filter and a coupling transformer. So this is the part of the STATCOM, and this STATCOM is connected in shunt with the power grid or power system through a coupling transformer. Now let's see what is a voltage source converter. This voltage source converter can be 3 level, can be 2 level based on the requirement. Now here this represents the voltage source converter or voltage source inverter, IGBT based. So this side will give DC and at the output side we will be getting the AC voltage. Now moving forward, as I said, the components of STATCOM are voltage source converter. So what is the purpose of using voltage source converter? This voltage source converter basically converts the DC input to the AC output voltage, and which will be fed to the power grid. Now basically the common types of VSCs or voltage source converters are square wave inverter or PWM inverter. Now what is a square wave inverter? This is an inverter which converts the DC input voltage to AC output voltage, and the magnitude of the output voltage can be controlled by controlling the magnitude of the input voltage, which is DC, because the output voltage is proportional to the input DC voltage. Now what is a PWM inverter? PWM inverter basically use the pulse width modulation techniques to generate the sinusoidal waveform from a DC input voltage, and IGBT based voltage source inverter utilizes fixed DC voltage to get variable AC at the output side. We need to control the modulation index of the PWM modulator. So by controlling the modulation index, we can get the variable AC output voltage at the converter output terminals. So we will be able to get the AC output voltage. Now if you see the diagram here, we will be able to get the AC output voltage at this terminal. Now this AC output voltage is not pure AC. So what we have to do? We have to pass it through the filter. So that's why this filter is used here. And also the coupling transformer, the reactance of the coupling transformer will also help to reduce the harmonics. So let's see the second component, which is DC capacitor. The DC capacitor, mainly it is used to supply a constant DC voltage at the input terminals of the voltage source converter, so that it will generate the AC output. And the inductive reactance is the, actually, as we have seen here, the transformer is used, the coupling transformer, this is having some reactance. So a transformer is connected between the output of VSC and the power system, and it basically acts as a coupling medium, means through the transformer will be able to feed the power or current to the circuit, or maybe sometimes it will absorb also. We'll go to this later on. So in addition to this coupling, transformer also neutralizes the harmonics which was obtained by the VSC. Now we have the next component, which is harmonic filter. It basically attenuates the harmonics and other high frequency component which was generated due to the use of voltage source converter. Now why actually this voltage source converter uh, generates harmonics? Because of the switching frequency. So that high frequency is attenuates with the help of the harmonic filter, and we can feed the pure AC voltage with the in the power system. So these are the components of a STATCOM device. So next, let's see how the STATCOM is basically works. This is the diagram of a typical STATCOM, where energy storage or a stored capacitor is used to supply the DC to the voltage source converter, so that it can generate the AC output voltage. Now the reactive current, whatever will be injecting or providing to the AC system, or maybe absorbing from the AC system, that actually depends on the generated voltage at the STATCOM terminals. So if the STATCOM output voltage is higher than the system AC voltage, then what will happen? We can see here that E is greater than V, means this current will flow from this higher potential to lower potential, means this device will inject a current into the circuit. That time it will actually work as capacitive compensator. Similarly, in opposite way, when this E is less than the VSC, the system voltage, that time the current will flow in the opposite direction, so it can work as inductive compensator, or we can say it will absorb the reactive power from the AC system. Now the amount of power or amount of reactive current is basically depends on what? If you see the diagram, it's basically depend on the STATCOM terminal voltage and the AC system voltage, the difference between these two voltages as well as the reactance of this transformer leakage reactance. Okay, so that reactance and the voltage difference decides how much amount of current will be flowing through this path. So the current which is flowing or which is generated with the STATCOM, so that also actually depends on the thermal limits of the IGBTs or the switches whatever is used in case of voltage source converter. So that also limits the amount of current to be transferred through the path. Now, the reactive and real power exchange between the STATCOM and AC system can be controlled independently. So, what is it actually? If you see the diagram, if it's a suppose it's a PWM inverter. In that case, what happens here? By changing the modulation index, we will be able to control this AC voltage. Once we will be able to control this AC voltage, we can be able to control the current through this, or maybe real and reactive power flow through this path. So that way, by controlling the output voltage of the STATCOM, we will be able to control the current flowing through this or power flowing through this path. So that way we can actually control them independently. By changing the phase angles also we can control it. So I will be moving to that point also. So in the next slides, any combination of real and reactive power generation or absorption is possible using the STATCOM device if it is equipped with a energy storage device of suitable capacity. Then it is possible to any combination means here it can either generate real power, absorb reactive power, generate both real and reactive power, absorb both real and reactive power, and absorb real power and generate reactive power. Any combination is possible with the help of this STATCOM device. Now we'll see that one also in the next slide. So let's take the VSE is the busbar voltage and or the voltage at which STATCOM is connected, and E is the voltage generated by the STATCOM. Now what is the power flowing through that path? Whatever we have seen, the power flowing through that path P is E VSE, already we know this formula, by X the reactance offered by that path and sine delta, and Q is given by this expression. Now when this delta is positive, that time what happens? Sine delta is positive. So ultimately the positive power, real power we are getting here. So that positive real power means it is supplying the real power to the power system from the STATCOM terminal. Now similarly, if delta is negative, then what happens? Our P becomes negative. So if P negative means what? It is absorbing the real power from the system. Now what is it STATCOM doing here? STATCOM is absorbing the real power from the system. So this way real power transfer through the path is possible. Now what happens if delta is 0? So when delta is 0, the real power transfer through the path becomes 0. What about the reactive power? The reactive power will be here. When delta 0, then we'll be getting there is no phase difference between the AC system voltage and the STATCOM generated voltage. So the power which will be flowing through the path, that will be purely reactive. Now let's see here. The adjusting the phase shift between the converter output voltage and the system AC voltage can similarly control the real power exchange between the converter and the AC system. As I said here, if delta is positive and delta is negative, means what? When delta is positive means what? The E leads the voltage by angle delta, and delta negative means what? E lags the system voltage, which is VSC by angle delta. So that way real power absorption and real power exchange, or we can say real power exchange, is possible with the STATCOM. So in other words, what we can say, converter can supply real power to the AC system from its DC storage energy if the output of the converter voltage is made lead to the AC system. So now as I said, it can absorb also real power when our P is negative, means delta is negative. Delta negative means when E lags the voltage by some angle. Which voltage? The system voltage. So this way, when see here is written voltage lags behind the AC system voltage. Now when delta is 0, as already I have mentioned here, P is 0. What is Q? Q is given by this expression. Now when E is greater than VAC, what happens? This here will get some value which is more than or greater than 1. So this Q becomes positive. So Q is positive means what? The converter is supplying power to the reactive power to the AC system, and as it is supplying reactive power to the AC system means it will be able to control the voltage, as voltage and reactive power is directly proportional. So in this case, SP is 0 means the STATCOM is supplying pure reactive power when the system voltage and the generated voltage at the STATCOM terminal, there is no phase difference that time. When E is less than VSC, the Q becomes negative. That Q is negative means STATCOM is now absorbing the reactive power, which is type of inductive. So that time, that means what? It will reduce the voltage at the point of connection. Now let's see the conditions of generation and absorption of reactive power, how this happens. Under normal condition means if the voltage of the AC system, that is VAC, is within the prescribed limit, then there will be no exchange of real and reactive power with the AC system. Now what happens when grid voltage or the power system voltage is above the threshold value? Then the STATCOM works as inductive element and it absorbs the reactive power from the grid. So this is the condition when this is more than this. So when that means Q is negative means it's absorbing. So it's as an inductive element. The STATCOM acts as an inductive element. Similarly, for grid voltage below the threshold value, that time this condition Q is positive. So it will be providing the reactive power to the grid, and which will increase the voltage at that point. So with the help of the STATCOM, it is possible to reduce the voltage as well as to increase the voltage and the power flow through the lines. So this way STATCOM helps to regulate the voltage at the point of connection by controlling the reactive power. The STATCOM is designed in such a way that it uh, the response of the STATCOM device becomes fast and convenient for maintaining the voltage during any fault conditions. So that way STATCOM actually provides the voltage short-term voltage stability or improves short-term voltage stability problems, as it can draw leading current as well as lagging current. So power factor correction is possible using the STATCOM, and as already we have seen, the reactive power flow control is possible with the help of STATCOM by making the output voltage at the terminals of the voltage source converter. By controlling that, we will be able to control the reactive power flow. Also the damping of low frequency power oscillation. How it is possible actually? That power oscillation generally takes place due to the variation of delta. So as we can control the power, so by supplying and absorbing this power, we will be able to damp the power system oscillation. Typically, the application of STATCOM in electrical power system are in electrical transmission system, electrical distribution system, and the network where heavy loads like industrial loads, arc furnace, or high speed railway system, and other electrical system where voltage stability and power quality are the utmost importance. There we need to install the STATCOM to improve the condition of the power system. So that way we'll be able to get the improved quality of power if we use the STATCOM in a power system. So that's all for STATCOM. Thanks.